In the last lesson, you learned how to find the area of a shaded region by subtracting the area of the unshaded region. Well, we're going to do something similar. We're going to find the area of two separate figures and add them together to find the area of another figure. So let's first find the area of this rectangle and the triangle. So here's our little line, a little dotted line. Let's find the area of the triangle. That is 3 units. And this is 1, 2, 3, 4, 5 units. So the area of the rectangle is base times height, 5 times 3 equals 15 units. Okay? Now the area of the triangle. Let's see. You've got the base, I'll do that different color. The base, which is 5, there's our right angle, and this height is 1, 2, 3, 4. So the area of the triangle is 1/2 base times height is 1/2. 5 times 4 is half of 20 equals 10. So the area of the trapezoid is going to be, with the entire figure, 15 plus 10 equals 25 units squared. So you can find the area of a trapezoid by making two shapes, if you're lucky. Now we're going to talk about the formula, using the formula to find the area of this trapezoid. Now, in a trapezoid, the bases are the parallel sides. Remember, a trapezoid is a quadrilateral with one pair of parallel sides. It doesn't matter if it's top and bottom or side and side. You find the parallel sides, those are your bases. We call them B1 and B2. So the area of this trapezoid is 1/2 times the height plus, get rid of the stray mark, times base 1 plus base 2. So the height, you're looking for a line that goes from the vertex to a base and makes a right angle. There's the height. The height is 7. The two parallel sides are this one and this one. So B1 plus B2, and it really doesn't matter which is B1, which is B2, because you add them. 15 plus 3 equals 18. So we have our pieces of information. We know the height, and we know the sum of base 1 plus base 2. So now let's plug in the formula. 1/2 times 7 times B1 plus B2 is 18, which is, well, we can do it that way. Let me tell you how I do it mentally. I do half of the even number. Half of 18 is 9. 9 times 7 is 63. Plug it into your, yard squared. Plug it into your calculator. And let's see if I'm right. 0.5 times 7 times 18. Yep, that's 63. There's your little mental math tip. When you're multiplying something by 1/2, find the even number. All right, let's try the area of this trapezoid. Here are the parallel sides. That was fun. Okay, anyway, the parallel sides are 7 yards and 19 yards. So B sub 1 plus B sub 2 is 7 plus 19 equals 26. Now the height, we're looking for it to go from a vertex to a base with a right angle. That would be this. So the height is 9. Now plug in your numbers. 1/2 times H times B1 plus B2 equals 1/2 times, is 9 times 13. Oops. 9 times 13, which is 117. Again, you can plug it all straight across in your calculator. I just multiplied the even number times 1/2. Let's go to the next page. Okay, we did finding the area of a trapezoid. We have that formula. 1/2 times the height times adding the bases together. Now in the rhombus, we're going to do a slightly different formula. Here, D stands for the diagonal. So it's 1/2 times diagonal times diagonal. So you need the length of each diagonal. You need to remember properties of a rhombus. All right, let's do some marking up on this one, okay? AC is 14, so that's one diagonal. We'll call that D1. D1. D1 equals 14. BE is 8. Well, if BE is 8, DE is also 8 because the diagonals bisect each other, which means DB, which is diagonal 2, is 16. You need to go and apply those things. You've got to remember what the diagonals do. If you're not sure, pop back to Unit 4. You should have the notes and look at some of your charts, okay? So if BE is 8, then DE is also 8. So the diagonal BD is 16. So D1 is 14, D2 is 16, area is 1/2 times 14 times 16, and I cannot do that one in my head. So 14 times 16 divided by 2, 112. 112 centimeters squared. So remember, the diagonals of a rhombus are not necessarily congruent, but the diagonals of a rhombus bisect each other. They intersect at a right angle and they bisect each other. Let's do another one. ED is 11. FD is 6. Let's make that neater. Sorry, guys. And FD, there we go, is 6. So here's ED and FD. Diagonals bisect each other. That means GD is also 11 and HD is also 6. So I'm going to make EG diagonal 1. I'm going to make FH diagonal 2. It doesn't matter which one is 1 or 2 because you're multiplying them. So D1 is 22, D2 is 12. So my formula, 1/2, 12 times 22. Oh, and I think that's 132. 6 times, yeah, 132 millimeters squared. Okay, remember your properties of diagonals. Now we're going to get into how to find the area of a regular polygon. To do this, you need to understand a few words. Regular, when we talk about polygons, means each side is congruent. So if a triangle is a regular polygon, it would be an equilateral triangle. All 3 sides are congruent. So let's talk about the number of sides. This really does play into what we need to know. Triangle has, well, we know this, 3 sides. Quadrilateral, 4 sides. Pentagon, we all have seen a picture of that building, 5 sides. Hexagon, 6. Heptagon, 7. Octagon, like a stop sign, 8. Next page, we're going to use this material. Okay, now we have the number of sides per figure. It's important you understand what they look like. Now, just because we call something a pentagon does not mean it has to have 5 sides the same length. So let's look at this. Which figure, A, B, or C, is a pentagon? We'll look for the one figure that has 5 sides. That would be figure C. Which figure is an octagon? You count them. It's obviously not B or C because you can't be an octagon and a pentagon. So it is figure A. Which figure is a hexagon? None of them have 6 sides, so none of them are a hexagon. Now, we're going to get into a word, it's a little bit of an odd word, called an apothem. An apothem is the distance from the center of a polygon to the side of that polygon, and it makes a right angle. If this was a circle, we'd call it the radius, but it's not. Okay, it's from the center to the side, not to a vertex, but to the side of a polygon, and it forms a right angle. So in this case, let's find our A and our P. Our A is 4. They show us right there. Perimeter. Well, how do we find the perimeter? We know the length of this side. The side is 3.3 feet. It is an octagon, which means 8 sides. So the perimeter is 8 times 3.3. 3.3 times 8, which is 26.4. Now we have our pieces. We put them together to find our big A area. 1/2 4, 26 times 4 equals 2 times 26.4 is 52.8 feet squared. Whoops, there's my decimal, okay? Big decimal. I simply multiplied 1/2 times 4 and got 2, and 2 times 26.4. You can do a lot of this in your head. Now I want you to pause this recording. I want you to figure out the area of the following shape. All right, let's do this. You've got a regular octagon with an apothem of 5.4. A equals 5.4, and a perimeter is 36. P equals 36. I want to find the area. 1/2 A times P, this goes into the calculator, 0.5 times 5.4 times 36, and I get 97.2 centimeters squared. The math in this is not difficult. It's knowing which value goes where. So that takes care of day 4. You now know how to find the area of a regular polygon, a rectangle, a trapezoid, a rhombus, a triangle, and a circle. Congratulations.